Hi, welcome to CNU Informatica. This is your Srinivas. Today topic is Pushdown Automata, which is related to theory of computation or formal language and automata theory. Why Pushdown Automata came into the existence means to overcome the limitations of finite state machine or finite state automata, specifically to recognize a broad classes of languages that could not be handled by finite state machine alone. Finite automata are alone capable of recognizing regular languages, which do not allow for nested or recursive structures. However, many computer applications, such as programming languages and arithmetic expressions, require the recognition of language with such nested patterns. While coming to the introduction of pushdown automata was also motivated by development of Chomsky hierarchy of formal languages in 1950 and 1960, which lead to the classification of languages according to their complexity and the type of machines that could recognize them. Context-free languages, which are more expensive than regular languages, required a new computational model, leading to invention of pushdown automata. The pushdown automata is a way to implement context-free grammars in similar way to define or design finite automata for a regular grammar in theory of computation. A DFA has limited memory. To overcome that, the PDAs came into the existence, and PDA can hold unlimited memory. Formally, we can say that PDA is finite automata machine plus stack. The components of PDA. A pushdown automata has three basic components. In input tape, it consists of input string. The input tape is going to dividing into the equal number of squares. Each square holds the each alphabet or symbol. We have the control unit, finite control unit. It takes an input and forwarded it to the stack for push or pop operation, to perform the push or pop operation. A stack is used to store the alphabet. It is act as a memory of infinite size. The following diagram explains the above components. This is the working of pushdown automata. We have the input tape and header and finite state controller unit and pushing the and popping symbols into the stack. Here the Z indicates that initial stack symbol. We can say that this is the top of the stack, or we can sometimes say that it is a null value. The PDA can be defined as 7 tuple formally, that is Q, sigma, tau, delta, Q, Z and F. Whereas Q is an infinite set of states, sigma is input alphabet with operations push or pop from the stack. Tau is the stack of symbols. Delta, or we can say the transition function, Q into sigma union epsilon into tau gives to Q into tau star. Here the Q is a start state or initial state. We can say that the small q belongs to capital Q. Z is the default value of the stack, or we can say that null value of the stack or initial value in the stack. We can say that Z is an epsilon. Capital F is a set of final states. F belongs to Q. The final states may or may not be exist in PDA. Depends on the constraint of the problem. We may generate a final state. It may not be generate a final state. The transition of PDA. The term transition refers to the change of state from one state to another state by reading input. It moves to the new state or it having the self loop in the machine when it reads the input symbol, including epsilon. The transition function can perform any operation like push, pop, and no operations. That means initially it have the current state is Q naught. By reading some input symbol A or 0 or 1, that will be pushed into the top of the stack, that is above the Q. This is the transition, how it is going to be represented. Delta capital Q comma Z is an input transfer function. It provides the output transfer function. First, in the input we can say that it is before the state before the transition, that is the capital Q. Input value is A or input symbol, we can say that Z is the top of the stack before transition. After transition, the Q will becomes the Q dash, that is it is going to be generating the new, moving to the new state. You can say that it is moving to the new state by reading the input alphabet A or symbol A or input A. You can say that by reading A as an input, moving to the new state, that A will be converted into X and placed or pushed into the stack, top of the stack, so that the stack contains X and Z. The top of the stack will be having the X. That is why X means A is converted into X, or you can directly push the A into the stack. Clear? A PDA, the transfer function is required when we want to perform any operation like push, pop, and no operation. By writing the transition delta of q comma a comma z equal to q comma xz. Here I consider that language L equal to a power n b power n such that n equal to 1. So that the string will be the AB. Clear? Or a power n b power n c power n such that n equal to 1, so that we can get the A, B, C. So here I have to compare that A, B, and simply I am going to read in the C. That means for by reading A, I am going to pushing the A into the stack. After A completion, I am going to read the B. Now I am going to compare in that A and B, so that I am popping the A from the stack. In this example, here I push the, after reading A converted into X and pushed into the top of the stack. Pop operation. Here the transition is delta Q comma B comma Z equal to Q comma Z. Actually here we are having that X as a top of the stack. So by reading B, I am going to pop in the X, so that it contains X comma Z. So after popping, the stack will be the empty. Now I am going to reading the next operation is no operation. In this, I'm going to reading the C variable or C alphabet. Just reading C, I am not performing any operation, and I'm going to changing the state, or I may change, or I may not be change the state. That is the transition function operations. Let us consider an example. Design a PDF for L equal to W X W reverse. W belongs to A comma B whole star. X belongs to sigma. That is input. Here for the given language, the accepted strings are like this. This shown in the green. AXA, AB, XBA, ABB, XBBA, AAA, BX, BAAA. These all are the accepted strings for the given language. The rejected strings are AB, ABBA. Clear? Here I am having the tape. Tape contain the considered string, that is A, B, X, B, A, epsilon. That is the string I considered. This is the header, read write header. This is a stack. Here I am going to using the stack. After reading the A value, I am going to pushing into the stack. The representation is like this: delta of Q naught comma A comma Z naught. I am going to read in the at the state of Q naught. I am reading the input symbol A. The stack is empty. After input transition, the output transition will be like this: Q naught. I am not changing any state. In the Q naught only, I am staying, and I am going to pushing the A into the stack. Now the top of the stack will be the A. Now the top of the stack will be the TP will be the top of the stack will be A. Clear? Next, the header will move right. Now it will be reach the B. The transition will be delta Q naught comma B comma A. Already stack contains the A. So A, on the top of A, the B is pushed. The push operation is performed so that A, B is in the BA is in the stack. Now the header will move right side. By reading X, I am not going to perform any operation. Just simply I am going to be changing the state. That is, here you can observe that in the transition delta Q naught comma X comma B, the top of the stack is B. Now I am reading the X here. Just simply I am going to be changing the state, and the top of the stack will be the B itself. Now the header will be moves to B, to read B. To read B here. The transition is delta Q1 comma B comma B. The top of the stack is B here. Reading symbol is B. Now I am going to be popping these two so that I am going to get the Q1 comma epsilon. If there is no element, then we can say that it is epsilon. These two are moving out so that we are going to get the epsilon here. Next, the header will move to next, right? That is reading A. Now the transaction of delta of Q1 comma A comma A, the top of the stack is A. The reading value, reading symbol is A. Now these two are the equal, so that I am going to popping A so that the stack contains the q1 comma epsilon. Now the header will move to read the epsilon. There is no string value in the input tape, so that the q1 comma epsilon comma z naught gives the q2 state and the empty stack. This indicates that the verification of wxwr is completed. At the last, we are going to read in the epsilon, that is completion of the string, and there is no element in the stack. The stack is empty, so that we can say that the string is accepted by the pushdown automata. This is the way we are going to be designing the pushdown automata. So here we have the read write header. It moves from left to right. Here we are going to writing the empty stack in the transition. Normally in the finite automata we will write delta q naught comma a, and after that we are going to move into the sum state. Here we are going to representing the stack symbol, stack also here. What is the stack symbol? Stack representation also here. For that I am going to include in the z naught. After reading the value or symbol a, the z will be a will be pushed into the top of the stack, so that it will be moves to here, that is representing here like this. Clear? That is the representation of transitions in the PDA. Thank you. I hope that you understand the concept of PDA, how it is working, how to write the transitions. Thank you.